Hello friends, welcome to our channel Knowledge Amplifier. And today in this particular video, I am going to discuss how we can build custom layers on AWS Lambda. Okay, so many times it happens that when we run a program in Lambda, we might get no module name NumPy, no module name Pandas. If you are using Python programming language, if you are using some other programming language, that time also I am pretty sure you might need some dependent libraries which is not readily available in our AWS Lambda console. That time what we do to avoid this kind of scenario, we basically download or install all the libraries in our development environment, that may be using PyCharm or some other development environment, right? And along with all those dependencies, we put our Lambda function, we zip them up, we upload that in our Lambda function. If it is having large size, we put in S3, and that S3 path we specify in our Lambda function. Like that we run, right? But this particular process is not good if you consider that flexibility is very less in this method. Like for example, the code which you have written in that zip file, now suppose there is some silly mistake, what you need to do? While doing testing, you understood that there is a mistake. Again, you need to modify the code, again make a zip file, again you need to upload in S3 location. So this is a time-consuming process. Apart from that, for example, you require Pandas and NumPy for a particular program. You have followed the zip file approach, and next time you are writing some other program where you require Pandas, NumPy. That time again for that environment also you need to install Pandas and NumPy and make a complete zip. You cannot use, or I can say you cannot reuse your earlier Pandas and NumPy, whatever you zipped and used in your earlier program, in this program also, in the zip file approach, right? That's why the Lambda layers came. So what it says, you basically install Pandas, NumPy or whatever your dependent libraries are in a particular folder structure, and that you zip, and that alone we upload and create a new Lambda layer. And when you are writing your program, that program will refer that particular layer if it requires some module. Okay, that is the simple thing. Now let me discuss how you can create the layer and how you can go ahead. Okay, so to solve the problem of zip file, putting the modules along with code and deploy in AWS Lambda, which basically makes whole system very large project and reduces the flexibility, to avoid that, we are basically going with this Lambda layer. And even the advantage of layer is it is reusable. Suppose you have created one layer one time, suppose there you have installed the request library Pandas, NumPy, and you are using that for a particular program. In some other program also you can use that layer. Okay, you no need to install Pandas and NumPy separately. Once it is done, you can reuse. So the complete picture kind of looks like this. That is, suppose you are the developer, you upload Lambda function, you upload Lambda layer. So for a particular function, there can be multiple Lambda layers. Some Lambda layers can be AWS managed layers, some can be partner or third party layers, where basically you are introducing some packages which are not supported by AWS Lambda by default, right? And then when the function will run, it will try to refer those programs, those installation packages, right? And it will import if necessary things are required. So this whole layer along with code will make our execution environment. So this is kind of decoupled architecture. Earlier one, when you are zipping the dependencies along with function code, that is a closely coupled, but this is kind of loosely coupled system, so where you can use the layers explicitly in other processing also. But you need to make sure that you are following certain folder structure, how you are creating the layer. Like I am going to consider Python. So for Python, your layer should be in Python folder, then inside that lib should be there, inside that Python 3.9 it is written here. So depending on your Python version, Python 3.7, 3.6, 3.8, 3.9, you need to write that here, and then here site packages we are writing. Okay, this should be the zip folder, zip file structure, right? So I am going to show you that. So what I am going to do basically, I am going to create a Snowflake table using our Lambda function. Okay, so Snowflake connector is not available in our Lambda environment by default. So this is the code. Import Snowflake connector as SF, And then here we created one function which is run query, which is taking the connection which is connected to the particular Snowflake account and the query parameter, whatever query we want to run. And then it is creating the cursor, it is executing the query, and it is closing the cursor. Okay. And here is our Lambda handler function where we are passing the default things like event and context. Here for creating the Snowflake connection, whatever required like user ID, password, account name, database name, warehouse name, schema, role we are specifying. And using this particular SF, which is basically Snowflake connector, we are creating the Snowflake connection. Okay, right? And then here we are basically using this statement, use warehouse, this particular warehouse you use. Okay, use database, this particular database you use role, that is this particular role you use, like that. Okay, and then we are using run query. So all this statement will be executed based on this run query function. Okay, right? And then it is going to create a test table. Okay, inside this particular schema what we are going to specify, right? And particular DB what we are going to use in this connection. So there we are going to create a test table where it will be having basically two columns. Call one will be integer type, call two will be string type, right? And then we are executing using run query. And then here SQL query data ingestion. This is another string where we are inserting two records in that test table whatever we have created. Okay, and then here we are executing run query. That's it. So this is the code. Okay, so let me go to AWS Lambda. I'll be copying this particular piece of code. So here I will go to AWS Lambda, and in Lambda I will go to functions. I'll go to create function. I will create a function Snowflake testing layers. Okay, and here I'll be giving, suppose I am choosing the environment Python 3.8. Okay, right? And I am keeping default execution role. I am going to create the function, right? So this is getting created. So here my Snowflake function is created. I will delete this particular piece and I will paste it here. So same code just now what I explained I have used. Okay. So user ID and password I will be specifying. Before that let me specify other things like account. Account will be, I will go to my Snowflake account and I will be taking this particular piece alone. And here I will be pasting. Okay, database name. Suppose I want to create my table in DemoDB. If I go there in public schema, you will see now currently destination table and employee table is present. But we want to create this particular table, that is test table. Okay, right? So that will test it out whether it is working or not. So database name, let me take from here. Maybe I can go to this particular table. Okay, and here place name in SQL. I can copy the database name from here. Okay, warehouse name. What is the warehouse? Our warehouse is compute WH, which is suspended. Maybe I can resume this. Okay, which is on, right? So compute WH. Okay. Compute warehouse schema. So schema I am going to specify as public schema only, not obviously not information schema. Role. What is the role I am going to use? sysadmin. Okay. You can specify your role. And user ID password something what I am going to specify after some time. And this is the same code. So let me specify the user ID password also, which I cannot show you. So right, I have specified the user ID password. So let me directly go to deploy. And then here I can go to test. And then here I can go to test. Okay. So something got failed. No module name. See, unable to import Lambda function. No module name Snowflake. Runtime import module error. So here import Snowflake connector as a safe. This is not available as a default version for our Lambda. So we need to put this. Earlier what we did using Windows subsystem for Linux, we installed all the packages. Now let me show you how you can do using EC2 instance. Okay. So we'll be launching one EC2 instance which is having Ubuntu system, and we'll try to run all these queries. I'll be explaining what are these queries. So before that, let me go to AWS, and here for creating for creating layers, I'll go to EC2 and I'll go to launch instance. Okay. here let me choose Ubuntu. Okay, right here Ubuntu, let me choose this particular one alone. And then here next configure instance, add storage, add tags, and keeping default values only. Review and launch, click on launch. So here I can create a new kpair and kpair name Snowflake testing layer. Okay, let me copy this and save this somewhere. Okay, kpair is this one. Okay, right now I will download the kpair, which will download a PEM file, and I'll click on launch instance. So here my Ubuntu instance will start running up. If I click on this, it is currently in pending state. Soon it will be running state. Okay. By that time, let me process the PEM file and let me generate the PPK file out of this. Okay. So here I will go to PuTTY-gen, right? And then PuTTY-gen. I will click on load. So basically I will load the downloaded file just now what I did. I will go to downloads, and then here I will choose all files, and then a Snowflake testing layer is coming up. Now here I will open this. I'll click on OK. I will click on save private key. I'll click on yes. I'll go to desktop. I will go to maybe asset, and in asset I will give the name Lambda layers. Okay. Here I am saving, right? So this saved. I can close this now and see the EC2 is running. Let me open this EC2. I will copy this public IP for DNS. I will go to PuTTY. I'll open this. I'll click on hostname. I'll go to SSH. I'll go to authentication. I'll browse the PPK file which just now I saved, Lambda layers, and here I'll click on open. So this is Ubuntu system, right? So user ID will be what? Ubuntu. Okay. Here is authenticating, and it is done. Our authentication is done, right? So now we are good to go ahead to install the Snowflake required dependencies. So for that you can refer this particular documentation given by Snowflake team. Okay. So I just paste this. Here you can clearly see install Python connector. What are the steps? So make sure first check the Python version. Okay. So let us go to that. Before that I will extend the setting so that it will not be connection out. Okay. If I write Python version, Python, let me check Python 3 version, maybe 3.8.5. Okay, 3.8 is installed. And if you see our Lambda we created also for 3.8 version only, right? So make sure that whatever dependent libraries you are installing, that is compatible version. Like Lambda is 3.8, we'll install 3.8 version compatible libraries or dependencies only. Okay. And in Snowflake documentation, you can clearly see the Snowflake connector for Python required this version 3.6, 3.7, 3.8, 3.9. So 3.8 we are having, we are all set, right? Okay. Now here what we will do, we will first execute this command which will update all the installation. Let it run. I'll be posting all this in the description box so that you can just copy paste. Okay. Then here we are creating the virtual environment for isolation purpose from the other environment. Okay. So once let this install, it is done, and then here we are installing the virtual environment. I will write yes, I want to do that. Once the virtual environment is installed, we will create one virtual environment with this name, Snowflake test. Okay, right? It is done, and here we have created one virtual environment. Once we created the virtual environment, we'll activate the virtual environment. Okay, right? We activated, see we are inside Snowflake test, alright. And then here if you want you can check the Python 3 version, not an issue. You can check 3.8.5, we are all set. Now here we will install Python 3 pip, okay, that is required for pip installation. I will write Y and I will continue the installation. Soon it will be installed. So it is done. Now let us go to next step. We are going to upgrade the PEEP. Okay, so the latest versions will be installed. So if you see the Snowflake documentation, they have clearly mentioned use this one, upgrade PEEP, install PEEP, upgrade PEEP. Okay, so I am just following those steps only, nothing else. Then I am going to execute this particular one. This is also taken from Snowflake documentation only. If you see here, that for Ubuntu system, as our EC2 is Ubuntu, so we are going to execute this particular code. Okay, that's what I have written here also, right? Install this, and then here, as I have told you while discussing the Lambda layers, that all the site packages should be in a particular structure. So like when you will be uploading in the Lambda layer zip file, it will expect that all the dependencies are in Python, then lib, then Python 3.9, depending on your version. Like for my case, it is Python 3.8, so I'll be using Python 3.8 here, and site packages like that. Okay, so here what I will do, I will execute this mkdir p. See, here I am using 3.8 because my Python version is 3.8. Okay, mkdir-p Lambda layers Python lib Python 3.8 site packages. Okay, so Lambda layers I am creating. So inside that, these particular things folder structure will be there. I will be installing the dependencies, and then we will zip up to this layer. Okay, right. You can follow the exact same process. mkdir is done. That is, this folder structure is created, and then here I will be going to that particular folder structure, cd, using cd, that is change directory command, and then here I have to install the Snowflake connector. Okay, so what this command is doing, try to understand this very carefully. Okay, so here make a note, this particular one is which Snowflake version, which connector version you want to install, that you need to specify. I am using 2.3.10. If you want some other version of Snowflake connector for Python, you can specify there. And here requirements underscore 3.8 is there because my Python version is 3.8. If you are using 3.6, then you should use 336. If you are using 3.7, you should use 37, like that. And we are using -t dot. That is, in this particular directory only you are asked to install this dependencies. Okay, so I'll be copying this particular piece alone, right? I'll go here, and here I'll try to copy. It is copied, and then here I'll be pasting that. Install it. What we are doing in the next step, here we have using this one, we are downloading all the dependencies from GitHub. Okay, and this is basically used to download actual Snowflake connector. So see, here we are specifying 2.3.10. Here also we specify 2.3.10. That's why we are specifying here 2.3.10. Whatever version you will specify here, that same version you should have to specify here. Okay, don't do mistakes here. Earlier I explained these things multiple times. That's why I am going this quickly. It is done, and then here I can install this one. Okay, so once that is done, I will go back till Lambda layer. Okay, currently my command, like my current directory is this particular place. I will be going till Lambda layer, and I will be making a zip, so that the zip file will be containing this particular structure. Okay, so I will execute this particular command to go back till Lambda layer in folder structure. Okay, so we are done. We are currently in Lambda layer, and what I will do, I will zip all of them. So to zip, first we should have zip installed, right? So we are installing zip. Yes, is installing, and then we will zip all of them, whatever is present. Okay, star. Let's say star and -r is given. That is, recursively it will zip completely, and will zip. So basically, expectation is in this particular Lambda layers, there should be one Snowflake Lambda layer dot zip. This kind of thing should be present. Okay, so let me open that. How I'll open? I'll open using QueenSCP. Okay, so what is my EC2 instance? If I go back to EC2 instance, this is my public DNS, which I'll be copying, and here this is my host name. Username is what? Username is Ubuntu. Password, I will be going to advanced, I'll be going to authentication. I'll be choosing the PPK file, right, which is stored in desktop, and then asset, and this is the Lambda layers. Okay, and then here login. Yes, and then here we are logging in. Okay, so see, this is our Lambda layers. If I click on that, here you will see Snowflake Lambda layer zip. This is created, right? So I'll be going back to my asset where our basically PPK file is also present. I'll be dragging and dropping this Snowflake Lambda layer. So this is completed. So once the zip is complete, I can basically drag and drop so that I'll be having that in Windows, and then we can create a Lambda layer, okay, in our AWS account. So it is done. So if I go back to asset folder, I'll go to desktop, I'll go to asset, and see here Snowflake Lambda layer is present. Okay. So if I open with Windows Explorer, you will see that the folder structure what I was talking. See here, for Python it should be Python. So first is Python. Inside that there should be lib. If you follow, here lib is present. Then after that 3.9 or 3.6 or 3.7 or 3.8 depending on your Python version. So here Python 3.8, correct. And then after that site packages should be present. So if I go here site packages is present. Inside that all the dependencies are present. So this particular one is ready, right? Now we are good to create our Lambda layer and use this. So I'll be going back to our Lambda. I'll be going to Lambda, and then here I'll be going to layers. I'll be going to create layer. Here I'll be doing layer testing. Okay, upload a zip file. Okay, for file larger than 10 MB you can upload from S3 also. So let me check how much size I am having. Go to properties and then 43 MB. Okay, it is having 43 MB, which is actually larger than 10 MB. So what I can do, I can upload in S3 location. I'll go to create bucket. Okay, bucket name, layer testing. Oregon regionally I am creating because our Lambda is also Oregon. Our Snowflake account is also in Oregon. Okay, then create bucket. Some random name I am giving as that name is already existing. Sorry. I'll go to create. Right. Bucket is created. I will go to here. So this is my bucket. Here I will upload. Add files. Okay. And here I will go to asset. Here Snowflake Lambda layer zip. This is what we want to upload. Okay. So it will take some time to upload in S3 location. So here in layer we can click on upload a file from S3, and then here we'll put our bucket name complete zip location. Absolute path. Okay. This uploaded. If I go to this particular one, here see zip location is present. I will just copy this particular S3 URL. I'll paste it here, right? And then here I can. So my layer name is layer testing. Let me save this first. Then that simply I am pasting. So that is my layer. I will go to create layer. So my layer is created successfully. So now if I go back to Lambda, and here we can click on layers. Here we can go to add layers. Okay. AWS layer specified by AWS or custom layer or specify a particular ARN. So here what it is telling, choose from layers with a compatible runtime and instruction set architecture, specify the Amazon resource name of a layer version. Okay. So let me go to specify an ARN, and I can go back to the layer which just now is created. Here see, the version ARN is present. I can copy this particular one and here I can paste this. Okay, right? Okay, I can maybe click on verify and then I can go to add. So it is going to add that particular layer in our Lambda function. See, layer is added, right? So before running this code, here you are seeing, if I refresh this particular DemoDB, you will see here no table with the test name present, right? Now let us go to test. No code change I did. Earlier same code was throwing error. Now let us create the test environment. Okay. So it's thrown error. What is that? Timeout. Okay, fine. Timeout we can change. We can go to configuration. We can go to general configuration and edit this timeout to maybe 4 minutes. 4 minutes 3 seconds like that. Save this, and then here we can go to test, and then here we can test it out again. Okay. So see, it is successful. See, no error we are getting now. Let us go back to Snowflake. So currently the table is not showing. Maybe let me refresh that. Okay. See, test table just now 10/8/2021 11:57 p.m. Currently also 11:57 p.m. right? So what we can do, we can go to place name in SQL. Delete this one. Place name in SQL, and then here I can write select star from, right, this one. Okay. If I run this particular one, see, we are getting these two records, whatever we try to insert here. 1, 2, 3, test string 1, 4, 5, 6, test string 2. Here also is 1, 2, 3, test string 1, 4, 5, 6, test string 2, right? So this is how we are able to connect with Snowflake and AWS Lambda, although in our actual Lambda environment, Snowflake connection is not available. This code I'll be posting in the description box to create the deployment zip file. Okay, to create the Lambda layer, whatever we use, that also I'll be posting. Okay, so this is the advantage. Once the layer is created, that is this particular layer, you can use this in your other code also. But if you are making a complete zip file along with code and dependent packages and put in SC location and use that time this flexibility will not be happening. And even if you go back to code, right, here in this code you can modify this. If some small error happened, you can modify this. But if you make a complete zip, that time each time if you get some error, that time you need to create each time a new zip file and put in SC location with the modified Lambda code. That is also flexible, right? Here we can modify the code if required. So this is the advantage of Lambda layers. Just make sure you are following this particular folder structure. For other programming language, these are the folder structure which should be happening. I hope you have enjoyed this particular video. This is all for this discussion. If you find this video helpful, then please like, share and comment. Subscribe to our channel if you haven't subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.